So in friction problems, we define the normal force as the force pressing the surface against the object. This resulted in drag. In our horizontal surface problems, the normal force was just the weight of the object. In ramp problems, the normal force will equal the force perpendicular. And normal means perpendicular. So this is a favorite kind of question right here, number 2. A 40 kilogram box rests on a 30-degree incline with a coefficient of friction equal to 0.300. Will the box remain at rest on the ramp, or will it slide down the ramp? Explain. So the first thing you need to do is draw a picture. So here is our ramp. This is 90 degrees. This one over here is 30 degrees. We have a 40 kilogram box. We know that the coefficient of friction is 0.300. That'll come in later. For now, we need to figure out the values of our vectors. So 40 kilograms, we know a couple of things. There's going to be weight. So that's Fg. And we know that weight is mass times acceleration. This is the mass, and the acceleration with weight is gravity. And so we know that this is 400 newtons. So we need to separate this weight component into the force parallel, going this way, and the force perpendicular, holding it against the surface. So here is the force parallel, and here is the force perpendicular. And we'll go ahead and label those. And you could make this into a parallelogram if you wanted to. This would be a right triangle here. Okay, so similar triangles. This angle was 30. That means this one is going to be 30. So let's look for the force parallel first off. So this one's also the force parallel. So the force parallel, here's my angle. We're talking about an opposite side, and we know the hypotenuse. Opposite and hypotenuse tells me that we need to use sine. The sine of 30 degrees equals the opposite over the adjacent, over the hypotenuse. Sine is opposite over the hypotenuse. And so the force parallel equals 400 times the sine of 30 degrees. So our force parallel is 200 newtons. So we'll go ahead and put that in our picture. Force parallel is 200 newtons. Then to find the force perpendicular, the component of the weight that is holding this object against the surface. So we have this angle 30. We're looking for the adjacent side. and we know the hypotenuse. The cosine of 30 degrees equals the adjacent, force perpendicular, divided by the hypotenuse. So here's the work that goes in my calculator, and the force perpendicular equals 346 newtons. So we'll put that in right here, 346 newtons. So we have the component pulling it down the ramp. We have the component holding it against the ramp. What we want to know is, will the box remain at rest on the ramp, or will it slide down the ramp? So here's what we're going to do. We are going to compare the force parallel, pulling it down the ramp, and the force of friction, which is holding it against the ramp. And so the force of friction, which we haven't drawn on here yet, is acting in this direction. There's the force of friction. And we don't know what it is yet, but we do know a few things. We know the coefficient of friction. So let's write this down. The coefficient of friction equals the force of friction divided by the normal force. And if you were to rearrange this, the force of friction equals coefficient of friction times the normal force. In this ramp problem, the normal force is perpendicular to the ramp itself. And so we're talking about the coefficient of friction times the force perpendicular. And then we can plug in some numbers. The coefficient of friction was given to us in the problem. The force perpendicular we found 346 newtons. And so the force of friction equals 104 newtons. So I can come up here and put that in my picture. So here's what's going to happen as we're comparing the force parallel and the force of friction. If the force parallel is greater than the force of friction, that means the force pulling it down the ramp is greater than the force holding it against the ramp and keeping it from moving. It's going to slide. If the force parallel is less than the force of friction, it's going to remain where it is. And so the answer here it will slide since the force parallel, which is 200 newtons, is greater than the force of friction, which is 104 newtons. We could go even a little bit further. We could figure out what its acceleration would be. So if we use Newton's second law, we know that acceleration equals the net force divided by the mass. The net force here, so we're talking about sliding down the ramp, only the forces going up and down the ramp are going to make a difference here. So we're talking about the net force equals the parallel force minus the force of friction divided by the mass. The parallel force is 200 newtons. The force of friction we found is 104 newtons. And the mass is 40 kilograms. So we have 96 newtons over 40 kilograms, which equals 2.4 meters per second squared. And it will accelerate down the ramp at 2.4 meters per second squared. Number 3, find the total force needed to pull a 60 kilogram box up a 25-degree incline if the coefficient of friction between the surfaces is 0.400. So the first thing we're going to need to do is just draw a picture. So here is our incline. We're going to make it into a triangle here. I know that we have a 60 kilogram box. I know that we have a 25-degree incline. Here's the angle. And we know the coefficient of friction is 0.400. So the first thing we need to do is figure out the weight. This vector pulling it down towards the center of the earth. This is Fg. So this one is 60 kilograms times the acceleration of gravity, 600 newtons. Then we have the components of this vector. So we have, here is the force parallel, and here is the force perpendicular. This is going to make a triangle, and this side of it will be force parallel. And this angle right here, 25 degrees. So here's what's happening. It's asking for the total force needed to pull a 60 kilogram box up the incline. And so we are going to be pulling in this direction. And we're going to need to find that. That'll be one of the last things that we get to. First off, let's figure out force perpendicular and force parallel. So let's do this one, the force parallel first. We have an angle, it's 25. This is the opposite side, and we know the hypotenuse. That means sine of 25 degrees is the opposite over the hypotenuse. (600) sine of 25 degrees. Parallel force is 254 newtons. So I'll put that in my picture, 254 newtons. And then I'll find the perpendicular. Excuse me, that was, put that in the wrong spot on my picture. That's why we use pencils. All right. So this one is 254 newtons. The force perpendicular, we're going to use the cosine of 25 degrees, and that is the adjacent side force perpendicular over the hypotenuse of 600. So the perpendicular force is 600 cosine of 25 degrees, and it is 544 newtons. Okay, so that's where we're going to put this. This is 544 newtons. So now we need to figure out how hard do we have to pull? What direction is friction acting? If we're trying to pull this up the ramp, friction is acting in this direction. It is opposing our motion. Whatever direction we pull, friction is in the opposite direction. So in order to find the force of friction, we have to use the formula that relates the coefficient of friction with the force of friction and the normal force. So the force of friction is coefficient of friction times the normal force, which is the coefficient of friction times the force perpendicular. 0.400 times 544 newtons, which we found here. So the force of friction is 218 newtons. Put that in my picture, 218 newtons. So in this one, what is the total force needed to pull? So we're looking for the pull. It's this force here. The pull in this situation is the net force. And we have a net force here already. We know what the forces are that are opposing us. We know the force of friction acting against us. And we know the force parallel, which is trying to pull us down the ramp. We need to overcome both of these forces with our pull. So the force of friction was 218. The force parallel was 254. And so our pull needs to be at least 472 newtons. A 100 kilogram box will slide down a 25-degree ramp at a constant speed, which remember means no net force. Find the coefficient of friction between the surfaces. Let's start with the picture. Here is my triangle. We know that the ramp is 25 degrees. We know that the object, the box here, is 100 kilograms, which means we also know its weight. Its weight directed towards the center of the earth is 1,000 newtons. So we split this into its components. We know that there is a force pressing it against the ramp, which is our perpendicular force, and there is a force pulling it down the ramp, which is our parallel force. So I'm going to make a triangle down here, and there's my force parallel. Our incline is 25 degrees, which means this angle is 25 degrees. And now we can get to work. The first things we have to do is figure out the force perpendicular and the force parallel. So the force perpendicular, we have an angle, we have the adjacent side, and we have the hypotenuse. That's going to be the cosine of 25 degrees is the perpendicular force over 1,000. Perpendicular force is 1,000 cosine of 25 degrees, which will be 906 newtons. That is the perpendicular force. Then define force parallel. So here's our angle, that's the opposite side, and we have the hypotenuse. We're going to use the sine of 25 degrees equals force parallel over 1,000. Force parallel is 1,000 sine of 25 degrees. So we find 423 newtons. So this is sliding down the ramp at a constant speed, which means no net force. So the net force equals 0. And let's put friction in on this picture. Here's the force of friction. It is opposing this object that's sliding down. We also know force parallel is 423. If there's no net force, so this is what it looks like. The force parallel minus the force of friction equals 0, which tells me that parallel force and the friction are equal. So the force of friction is 423 newtons. Find the coefficient of friction between the surfaces. We're looking for mu, the coefficient of friction. So the force of friction over the normal force, which means the force of friction on a ramp problem over the perpendicular force. So 423 newtons divided by 906 newtons. We find the coefficient of friction of 0.467, and there are no units because newtons cancels out on top and bottom.